Okay, so let's start with question number 8, exercise 12.3. So the question says you need to find the distance around the track along its inner edge. So we need to find the distance of the track here. So first of all, we need to consider these two straight lines, this one and this one. So this will be 106 plus 106. Now we need to find this curved area. And this curved area is nothing but the circumference of semicircle. So we have two semicircles here. So it will be half 2 pi r plus half 2 pi r. So it will be 106 plus 106 plus pi r plus pi r. As they are both same, so I would be adding pi r and pi r. So that will be 2 pi r. So 106 plus 106, 2 is there, 22 over 7. R value in this case is given to us as 30. So I will be considering R in this case as 30. So 212 plus 1320 over 7 equal to, by taking LCM, you will get your answer as 2804 over 7 centimeter. Now we need to find area of the track. So in case of area of the track, we need to cover this blue part shaded in this diagram, figure 12.26. So first of all, as you can see, we have two rectangles present here. So we'll be finding area of two rectangles. That will be same. The width given to us is 10. So length is 106 and breadth is 10. So 106 into 10, 106 into 10 plus. Now as you can see that we have two semicircles here, this and this. So we need to subtract. I would be considering this part. I would be redrawing it. So we need to find the area of this part. So how to find? Now I would be taking the diameter for this, the smaller one, and the radius for bigger one will be 40 because the width for the track is 10. So that means my radius for smaller one is 30 meter and radius for bigger one is 40 meter. So you can take the area of bigger circle minus area of smaller circle. That will give you the shaded portion. Not circle, it will be a semicircle. So twice of half 22 over 7, this will be 40 square minus half of 22 over 7 and this will be 30 square. Now 106 into 10 will be 1060. So twice of 1060 will be 2120 plus, solving this part I will get 22 over 7, as 1 by 2 and 2 will get cancelled out. So 40 square minus 30 square. So 2120 plus 22 by 7. 40 square, you can write it as a minus b and a plus b form. So 2120 plus 22 over 7. 40 minus 30 is 10 and 40 plus 30 is 70. So the final answer to this is 4320 meters square. Let's move on to question number 9. Now we need to find area of shaded region in this case. So first of all, I will find area of circle with diameter OD here. So first of all, I will write the formula like how to find area of shaded region in this case. So it will be area of circle with diameter OD plus area of semicircle ACB, this part, the half semicircle. Then take away area of triangle ACB. So area of circle with diameter OD will be pi r square, that is 22/7 into 7 by 2 whole square, plus area of semicircle ACB will be half of pi r square. So pi is 22/7, r square. R is 7 here, 7 square. Area of triangle ACB will be half base into height, that will be 7 into 7. So quite easy. So let's solve this. So this will be 77/2. This will be 77. The last one will be 49/2. So taking LCM as 2. So the upper part will be 133. So 133/2 will be 66.5 centimeters square. That's the answer for the question number 9. Let's move on to question number 10. So in this case, we need to find smaller shaded portion. So for this, as you can see, we are given with area of equilateral triangle here. The the area is already calculated here. We need not to find anything. So in this case, first of all, it will be like this. I hope all of you know that what area of equilateral triangle is. It is under root 34 a square. So I will equate it to 17,300.5. So a square will be using cross multiplication. It will be, when you solve this part, you will get your answer as, let me solve for you. So let us find what will be the answer. As you can see that under root 3 value is already given to you. So let's put this 1.73205. Now, as you can see that these values are quite similar. Only the difference is that they have different point. So how to remove this obstacle is by removing point. So if you want to remove this, you will write 10 at denominator, and if you want to remove this, you need to multiply it with 5 zeros at numerator. 3, 4, 5. Let us remove this part. So cut down 0 with 0. So you are left with a square as 40,000. So square value for this will be 200 square. Cut down square with square. So A is 200 centimeter. Now we need to find area of shaded region. So for that, first of all, we need to find area of triangle ABC. ABC is given to us, that is 320.5. Then you need to remove area of these three sectors. So let us write this. Area of shaded region is equal to area of triangle ABC. Then remove area of three sectors. So area of triangle ABC will be 17,320.5. Take away area of three sectors. So as you know that area of equilateral triangle is, the angle for equilateral triangle is 60 degree each. So angle A is 60, angle B is 60, angle C is 60. So 60 degree over 360 into pi r square, 3.14. R square will be 200 divided by 2. So this will be 100 square. Let's solve this part. 1 by 6 into 3.14, 100 into 100. So cut down 3 and 6 with 3. So it will be 50 here. 17,320.5. Take away 15,700. So the final answer for this is 1620.5 centimeters square. Let's move on to question number 11. So on a square handkerchief, 9 circular designs each of radius 7 centimeter are made. Find the area of the remaining portion of the handkerchief. So radius of each design is 7 centimeter. We need to find area of the remaining portion of the handkerchief, means this part. So first of all, we need to find area of square. So how to find area of square is, as you know that the radius for one circle is 7. That means diameter will be 14. So 14, then 14. So the total side of square will be 14 times 3. That is 42 centimeter. So let us find area of square first. So that will be 14 square. 14 square is nothing but, sorry, that will be 42. 42 square, because one side is 42. So 42 into 42 will be 1764 centimeter square. Now we need to calculate area of 9 circular designs here. So for that you need to find area of one circular design. So area of one circular design will be pi r square, 22 by 7. R will be 7 square. Cut down 7 with 7. 22 into 7 will be 154 centimeter square. Now for 9 it will be times with 9. 9 into 154 will be 1386 centimeter square. Now we need to find the area of remaining portion on the handkerchief. So it will be area square take away area of 9 design, circular design. So area of remaining portion, it will be 1764 take away 1386. So it will be 378 centimeter square. Now let us move on to question number 12. It says OACB is a quadrant of a circle with center O and radius 3.5 centimeter. If OD is equal to 2 centimeter, find the area of quadrant OACB. So we need to find first of all quadrant area. So quadrant is always 90 degree, as you can see. So 90 degree over 360 pi r square, 22 over 7, r square is 3.5. So 90 over 360 will be 1 by 4. Removing point here. So 5, 4 and 22 will be 11 by 2. Now when you solve this, you will get your answer as 77 over 8. So the answer is 77 over 8 centimeter square. Now we need to find area of shaded region. So for area of shaded region, we need to remove the area of triangle OBD in this. So we need to remove this part. So let us remove OBD triangle from quadrant OACB. So the second part will be area of quadrant OACB, take away area of triangle OBD, that is half OD. So area of quadrant is 77/8 and half OB times OD, that is 3.5 into 2/2. So let us take LCM for same. So when you take LCM, you will get your answer as 49/8 centimeters square. So we'll meet you in the next class.